In episode 34 of the CySec101 training series, we're going to go through OWASP Top 10, which is a very powerful list or a standard for web application testing. And this is a part of the web hacking module that is a part of the Cybersecurity 101 pathway of TryHackMe. And as a part of this video today, as a part of this training series, we're going to be going through the top 10 list as far as the description of the challenges themselves are concerned. And this is a little bit of an older room that is in TryHackMe, because this is actually the 2021 list, and they actually just created, or I think they're wrapping up the 2024 version of the OWASP Top 10. So we're going based on the most recent finalized published version, which is the 2021. And as a part of that list, we're going to look at them from the top. So for looking at the very first vulnerability, the open web application standard, we're going to be looking at the broken access control, and then we're going to do an exercise for it. Then we're going to do cryptographic failures and do a couple of exercises. Then we're going to do injection, insecure design, security misconfiguration, vulnerable and outdated components, and then identification, authentication, software and data integrity failures, security logging and monitoring failures, and then server-side request forgery. And for all of these things, there's going to be, or at least for most of them, there's going to be a practical exercise that we're going to run with the virtual machine that we've been assigned. And this is actually a free room that's available on TryHackMe. So anybody, as long as you have a free account with TryHackMe, you can go ahead and run the virtual machines, run the attack box, and then do all of the exercises that we're going to end up doing inside of this training video. So hopefully you have your membership of TryHackMe. If you don't, this would be the perfect time to go ahead and get it. And that way you can run across the rest of these exercises and the rest of this video with me. If you'd like to support this channel, consider joining Hackaholics Anonymous, the premier YouTube community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master. And each tier gets their own Discord server and early access to content. The agent, guardian, and master levels, however, get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the OWASP Top 10 room. Okay, so the OWASP Top 10 is the Open Web Application Security Project, which is a nonprofit foundation focused on understanding web tech and exploitations, and provides resources and tools that are designed to improve the security of software applications. And they come out with a top 10 list for, I would say, maybe every 3 years, something like that. So the one before the 2021 version was 2017. So every 4 years, I guess, because now we have the finalized version that's coming out sometime in 2025, it seems, because as I'm recording this video, it is already 2025. So if we actually look at the OWASP Top 10 on their official website, it is giving us the OWASP Top 10 2025. The current status as of September 2024 is that they're planning on releasing it in 2025, in the first half of 2025. And then the version that we see on their website is still the 2021 version. So it does seem like it's going every 4 years, and the most recent version, which is the 2025 version, has not been released. I feel very confident that when it does get released, TryHackMe is actually going to put out a training room and a training series just for that. So as soon as that comes out, we'll just have an updated version of this video for you. But for now, for people who are studying cybersecurity and they're inside of the CySec101 playlist and following along with this training series that we got, this is the most recent version, which is going to be broken access control, cryptographic failures, injection and secure design, security misconfiguration, vulnerable outdated components, identification, authentication failures, software and data integrity failures, security logging and monitoring, and server-side request forgery. I know I already announced that, but just in case, just wanted to go over it at least one more time with you. And that's basically what we're going to be doing. And it's been designed for beginners. So this room and this video is for beginners, but we're actually going to be doing some pretty cool exercises that even as a beginner, as a complete greenie, you're going to get a lot of value out of. So I'm actually really excited about this video. I've already launched the virtual machine, and all you have to do when you join this room, because again, this is a free room on TryHackMe. You click this button. This is originally a green button, this shade of green right here. You would click that and it would start your victim machine for you. And then you got to go up here and there's a button up here for start attack box. So right now, so let me actually, if I exit split view, right here where it says show split view, this originally says start attack box. And then once you've started the attack box, it turns into show split view. And then when you click on that, it'll actually open up the attack box for you. Usually when you click start attack box, this split view automatically opens up anyway, so you don't have to worry about it. And I'm just going to give it a couple of seconds because I feel like it's taking a little bit of time for this thing to load right here. But for the most part, we have our victim machine that's up and we have our attack box that's up. So let's talk about the first vulnerability inside of the OWASP top 10, which is the broken access control. In order to understand broken access control, we need to first understand what access control is. And we can generalize it into two main categories. You have privileged users or administrators, and then we have regular users. And the visitor of a website could also be considered a regular user. And so for somebody to be able to access a website, they would need to have one of those two sets of credentials. Now, what happens is when somebody who is not an administrator, when somebody who's a regular user gets to access the privileged data, that would be considered broken access control, meaning the stuff that they should not be able to see, they are now getting to see, and it's because their access, the control that is assigned to their access level is broken. So that's what broken access control really means. So only the site admin user should be able to access a page to manage other users. As an example, if a visitor can access protected pages that they're not meant to see, then the access controls are broken. So a regular visitor being able to access protected pages can lead to being able to view sensitive information of other users, accessing unauthorized functionality, doing things that they shouldn't be able to do. So simply put, broken access control allows attackers to bypass authorization. And this is a part of authentication and authorization frameworks and modules, and then this falls under the IAM, Identity and Access Management. So there's a lot of stuff that essentially covers this specific vulnerability, but it's a really big one, which is why this was listed as the #1 vulnerability in 2021, because if people can get access to pages or to assets or to resources that they shouldn't have permission to access, that's a really, really big deal. So a vulnerability was found in 2019 where an attacker could get any single frame from a YouTube video that was marked as private, and the researcher who found the vulnerability showed that he could ask for several frames and somewhat reconstruct the video, since the expectation from a user when making a video as private would be that nobody has access to it. This was indeed accepted as a broken access control vulnerability, and this was as recent as 2019, which is, I guess it's not that recent. Time is kind of flying by. So it is technically 6 years ago, but it is against a company that's massive like YouTube. So it's not a small company. It's literally a company that's bordering, I mean, it's definitely in the tens of billions, if not hundreds of billions of dollars. So it's a massive, massive company, and it belongs to a massive company like Alphabet. So you would kind of expect that they would have their security in order, but they don't, right? So that was the example that we have for broken access control. Now let's look at the actual exercise here. We actually have a challenge called the EDOR challenge. Now, the EDOR challenge is, EDOR stands for Insecure Direct Object Reference, and we have a direct object that is, in this particular case, let's say ID number, 111111, right? That's technically the object that we are referencing inside of this specific website, or a direct object that we're referencing. So when you have an insecure reference, means that if I change this ID number to 11111112 or 111112 or whatever, any other ID number, and I get access to that ID, that means that I now have access control that I should not have, right? So if this is my bank account number, for example, and I'm able to if I'm able to access my own bank account information, that's great. But if I can access somebody else's bank account, that becomes a really big issue. And now I can transfer money out of that person's account into my own account, right? I could do a lot of things that I shouldn't be able to do with somebody else's bank account number. So this occurs when the programmer exposes a direct object reference, which is just an identifier that refers to specific objects within the server. By object, we could mean a file, a user, a bank account in a banking application, or anything really. So this is the example that I just gave you right here. So potentially a huge problem, because if I can change the ID parameter to like my own bank account number, or not even that, somebody else's bank account number, and then transfer from this account number to my own account number, then that is a big broken access control vulnerability. So the application exposes a direct object reference through the ID parameter in the URL, which points to a specific account. Since the application isn't checking if the logged in user owns the referenced account, an attacker can get sensitive information or transfer money, which is the big piece right there. So notice that the direct object references aren't the problem, but rather the application doesn't validate if the logged in user should have access to the requested account. So we are going to read and understand how this works, and now we're going to deploy the machine and go to this specific website, log in with that username, and then do some other things that we shouldn't be able to do. That is the whole purpose of the eDoor. So let me just open my browser and I'll go to this website, and then we will look at all of the user notes to be able to find this flag that we have at the bottom right here. Okay, so this is our website, okay? And as soon as we log in, we get a note basically that is like it's a shopping list. It's actually a shopping list. It's not like a shopping list. So the vulnerability is up here, right? And the question is asking us to go through all the notes, and then what is the flag, right? So we're basically supposed to go through the rest of the user notes that are available here. So I can start from user 0, I want to say. So I can technically go to ID 0, and then from there see what we can get for ID 0. And this is very slow to respond right now. I think it's because it is a free room, that maybe there are a lot of people that are using it, or maybe they didn't give us the fastest virtual machines that they have, because technically it is a free room. So it could also be because I'm recording and I may be down to like fumes when it comes down to the battery on my computer. Oh, flag 0 actually is the flag, or ID 0 is the flag that we have over here. So that one was actually kind of quick, thankfully, because this thing really is slow. But technically I could actually, so I started as ID 1, I just looked at ID 0, I can go to ID 2, press enter, and I can also see the notes for ID 2, and then you can just keep going, right? And this is where the eDoor vulnerability typically exists, and it could be something like a ID parameter, or it could be any other parameter that you can modify that you shouldn't be able to modify, and then get access to notes that you shouldn't have access. So you're not supposed to see this node, which means you're on the right track, right? So this is what we were doing. So the answer was at ID 0. That's basically where the flag lies. And then when you get that flag, this would be the answer 543. So that was the flag that we got for the exercise that we are running inside of the Broken Access Control Challenge. So now let's look at cryptographic failures. So we did a series of videos already on the CySec101 playlist that has to do with cryptography and encryption in general. There was the Cryptography 101 and everything else that came after that. I think there's like a total of 3 videos that we did on CySec101 playlist that has to do with cryptographics, encryption, cryptography. And a cryptographic failure is basically any vulnerability that has a misuse or a lack of use of cryptographic algorithms for protecting sensitive information. So either it was a bad algorithm, like an old algorithm that is easily decrypted, or there was no algorithm. And that is probably like the biggest thing, right? So for example, if we have an email application and you're accessing your email account using the browser, you want to be sure that the communication between you and the server are encrypted. That way, any eavesdropper trying to capture your network packets won't be able to recover the content of your email addresses. When we encrypt the network traffic between the client and the server, we usually refer to this as encrypting data that is in transit. And then since emails are stored in some kind of server that's managed by a provider, it's also desirable that the email provider can read the client's emails, and encrypting that is called encrypting data that is at rest. So when data is being transferred back and forth, and it could literally be the email that's also flying through the ether to actually get to whoever the recipient is, that could be data in transit. It could be data that as you're logged into your email, you're looking at the data that's being passed back and forth. As soon as you receive an email, that's technically data that's being transferred to you live from the server to your client, which is your computer, your web browser. So when you're looking at data in that regard, card, that is data that's in transit. It's going back and forth. And then you're looking at data that's sitting on your computer, or it could be sitting on a server somewhere. Nobody's accessing it yet. But even though it's not being accessed, it doesn't mean that we don't want it to be secured, right? So that would be encrypting data that is at rest. Now, cryptographic failures often end up in web applications accidentally divulging sensitive data. And this often directly links to customers, like the names, date of birth, financial information, but it could also be more technical information like the usernames and passwords. And at more complex levels, taking advantage of some cryptographic failure often involves techniques like man-in-the-middle attacks, where somebody's literally sitting in the middle of the transit, that data that's going back and forth. They're just watching all that data that's transferring, and they're the one in the middle, and they can capture everything and either modify it or just steal the data. They would force user connections through a device that they control. Then they would take advantage of weak encryption on any transmitted data to access the intercepted communication or information, if the data is even encrypted in the first place, assuming that it's not plain text. So, of course, many examples are much simpler, like vulnerabilities that can be found in web applications that can be exploited without advanced networking knowledge. Indeed, in some cases, the sensitive data can be found directly on the web server itself, and the web application in this box contains such vulnerability, and we're about to exploit it, which is the cryptographic failure exercises that we are about to run through. Supporting material number 1 talks about the most common way to store a large amount of data that is in a format that is easily accessible from many locations and that's called a database. And it's perfect for something like a web application because there are a lot of users that interact with it, and they usually follow SQL, which is the structured query language syntax. And we also did a video on SQL in the CySec101 series, and it's a good one. It's actually a strong one, and we do a lot of exercises that are very useful. So I would recommend you watch that if you haven't seen the SQL video. It is in the CySec101 series, and you can find the title SQL Basics. So in a production environment, it is common to see databases set up on dedicated servers running a database service like MySQL or MariaDB. However, databases can also be stored as files, and they're referred to as a flat file database, as they are stored in a single file on the computer. And this is much easier than setting up an entire database server and could potentially be seen in smaller web applications. Accessing a database server is out of the scope of today's task, but again, you can go ahead and go to the SQL Basics video in CySec101 playlist, and you'll be able to go through all of those exercises. And it is a good in-depth exercise, even for beginners. I think it's really, really fun. As mentioned previously, flat file databases are stored as a file on a disk on a computer. This would not be a problem for a web app, but what happens if the database is stored underneath the root directory of the website, which means of the files that are accessible using connecting to the website, and we can download and query it on our own machine with full access to everything in the database, and that is definitely sensitive data exposure. So that is not good. And it's a big hint for the challenge that we're going through. So let's cover what the syntax would be to query a flat file database. The most common and simplest of the flat file database is the SQLite database, and it can be interacted with in most programming languages and have a dedicated client called the SQLite. And this one we're running SQLite 3. It's installed on many Linux distributions by default. So if you run ls, which is the list command, and I'm not going to go through the basics of the Linux command line, so we're just going to run ls as an L just to see what is available and what the permissions are, and that would be the example.db file. And if we look at the file of the file type of that, it's going to say that it's a SQLite 3 file. Now, if we actually do SQLite 3 and then do example.db, what's going to happen is that it's going to open up example.db using SQLite, and then we'll be able to actually pull the tables, for example, that are inside of the example.db, and then we see that we have a customers table, and then you can do pragma and then do the table info customers to actually get the columns of the table customers. And you'll see the column 0, which is the first one, is the customer ID, I believe. And then we have customer name, credit card information, and password. And then you want to select everything from that table, and you're going to get the ID of each customer. You're going to get their name, their freaking credit card information, and of course their password hash. So we're not getting the plain text version of the password, which is nice, I guess. But we are absolutely getting their freaking credit card, which is crazy. So the first one would be Joy Paulson, right? And this is what her data shows us. So in the next task, we're going to actually look at cracking the hash that's available for Joey Paulson. And there's a lot of really freakishly easy ways to crack a hash, which is, it just goes out to the cryptographic issue right there. So this one is going to be done with CrackStation, which is my favorite tool for doing it because it's a free website and it's super easy to use, as you'll see. And we did also cover this when we went through the cryptography video. So when it comes to hash cracking, Kali Linux comes pre-installed with a lot of various tools, and it's because Kali Linux is designed for penetration testing. So there's John the Ripper, there's Hydra, there's a lot of different tools that are available on Kali Linux that you can use to crack password hashes. Now, let's say you don't have Kali Linux, but you have you found for whatever reason a list of password hashes. You can go to this little website right here, which is called CrackStation, and it is you literally just paste the hash in here, click I'm not a robot, and crack hashes. And as long as it's one of these hashing algorithms that we have down here, so it's the LM, NTLM, MD2, 4, 5 hex, MD half, or MD5 half, and then we have the SHA series, and it goes up to SHA 512. Now, the thing that we need to understand with password hashes is that you're not decrypting a hash. You can't dehash a hash. But what's going on is that there is something called a rainbow table. And a rainbow table, is a glorified spreadsheet, basically, that for each hash, okay, there's a plain text value that is stored on that row for that hash. And so when you pull these hashes up over here, it's not decrypting anything for you. It's just looking at this massive database that's stored on a spreadsheet, and it's saying, oh, we do have the value for this particular hash, and then it'll give us this hash. So this is where it comes down to, you want to have really secure passwords, because if you have a secure plain text password, like a really long, download CrackStation's word list, right? This could be the password file, or the password itself. And then if that's your actual plain text password, when the SHA-256 hash value is created, that won't be on anybody's password list because it's a complicated password. It's a long password. It doesn't count as an easy password. Therefore, it's not going to be stored inside of a password list like what CrackStation has over here. So again, we can't dehash or decrypt hash values, but we can check a massive database or use a dictionary or something like that. And from there, and I'm not referencing like a regular dictionary, I'm talking about the dictionary that we would use with a tool like Hydra or John the Ripper to actually crack a password hash. And then when we do that, you're looking at just a massive database or a massive dictionary password list, and then comparing what you already have against that to see if you can hash it or dehash it, So if we look at this one, this would actually be something that does exist most likely inside of their database. And if we do it, it'll say, yep, we have it. And that is, of course, it's like a default password in a lot of systems, which is the word password, all in lowercase, no special characters. And this specific hash type is an MD5 hash type, which is one of the older hash types. And it's not, for example, comparing it to SHA-256, which is a 256-bit. This is, I believe, a 32-bit, meaning it's 32 characters long. And again, I'm not going to go deep into the explanation of hashes because you could literally just go and look at the cryptography videos that we have, and then you can do a deep dive into hashing. So we're not going to go too crazy with that right now. It's good to know that Cryptographic Failures is actually one of the OWASP top 10 list. And then from there, if you actually find a list of password hashes, you can write a very simple script that says, hey, I want you to run every single password hash in this thing against a database like CrackStation's word list. And then from there, just see which one you actually find the plain text value for me. So pretty insane. Now we can actually do the challenge of going to this website and then getting the password hashes. All right, so the first question or the premise, it says, have a look around the webpage. The developer has left themselves a note indicating that there is sensitive data in a specific directory. So if we look at the webpage, there's really nothing clickable on this webpage other than, I think, just the picture itself. And maybe it's not loading for me. I'm going to open this up in a full screen mode just so we can see what we can actually see here. And hopefully this will be a little bit easier for us to manage. So again, this is kind of slow. So I'm going to give it a second to load, and then, oh, there we go. It actually loaded, but it's not fully loaded. So let's see how quickly it'll respond if we are in full screen mode. Okay, so there were literally only two clickable elements on this web page. One of them is the contact us element, which is on the home page, and that just opens up the email application and has you try to email whatever their contact email is, and then which is right here. It's the please contact us here, and when you click on that, it opens up the email application. And then the other one is the login page that's in the corner right here. So when we click that, it actually just takes us to a login page. And then if we right click on the page and then look at the source code, right? So if I go and click on that view source code, it'll open up the actual source code of the website for me. And then right on the source code, there's a comment that's been left by the web developer right in the middle of the page where it says, must remember to do something better with the database, then store it in assets. So /assets is the path for where the database itself is stored. So now we can go look at what is inside of that directory. All right, so when we go to the assets page, so it's basically the IP address. I had to refresh, so it's a different IP address, but it's still on port 81 and then /assets. When we go to that, we get this little gem right here. And then so we have the webapp.db, which is our database file. We have the JS, images, fonts, CSS, and of course the parent directory. And the parent directory brings us here. And then the assets page, CSS, will take us to the CSS style sheets. The fonts will bring us to the fonts, of course. Images will bring us to the images, the two images that are there. And JavaScript will take us to the JavaScripts, the console script, and the jQuery mini. And of course, we have the web app database, which is a file that downloads. So I just downloaded that file. So we have taken care of the top two questions, which is what is the name of the mentioned directory, and navigate to the directory, and which file stands out, which is the web app database. So it says use the supporting material to access the sensitive data. What is the password hash of the admin user? So let's go ahead and actually access that downloaded file. I'm just gonna go click on that downloads button, and then when I click on this little folder, it opens up the downloads, and we have that. So let's go and we will do this. So we're going to use the terminal, and then we're going to go to the downloads folder here, and essentially what's going to happen is we're going to use SQLite. I want to say it's SQLite 3. SQLite 3 maybe. And then let me actually go to the downloads folder first, so we are not there right now. Oh no, it's actually in the desktop. So we'll do SQLite 3, and then we will do webapp.db. And there we go. And if we do, I think it was .tables, sessions and users. So we want to get the data for the users, and it was pragma. Let me make sure I get into caps lock. So it was pragma, and then it was, what was the command? So let me get the command one more time here. Table info customers, that's what it is. So pragma table info, and then we want users, and then we would do you got to do a semicolon at the end of every SQL query, essentially. So we have the user ID, username, password, so on and so forth. And then so what we're going to do is we're going to select everything from users, and then we'll do a semicolon, and then press enter. And then so this is what we got. So we got the user ID, which is going to be what is it? It's this thing, I guess. That's their user ID, which is insane if you think about it. And then we have the password. No, so user ID, yeah, user ID, username right here, and then password, and then admin. So whether or not they are an admin, I would assume that's what this last piece is. So if it's a 1, that means it's true. If it's a 0, that means it's false. So these guys are both admin, and and then the actual admin user, their password hash is in position 2, or technically position 3, because position 0 would be the first one, which is everything here, and then we have the actual username, and then we have admin's password hash. So that is admin's password hash. So we would copy that, and then we would go to our question right there. So that's the password hash. And then what is the admin's plain text password? So we would then take that hash and we would go to crack station, crack the hash, and then it is QWERTY UIOP. So if you have your fingers on your home buttons on your keyboard, so your left index would be on F. So if you just go to the top row and you put your pinky on Q, you would just do QUERTY and then UIOP. Literally every letter that's in the top row, that's his password. That's the admin's password. Goodness gracious. Okay, so there we go. And then we got the crack the hash of the admin, which is QWERTY. So login as admin, what is the flag? So now we have the admin's password. So what we're going to do is we're just going to go to the home page. And let me actually just do that. I'll just do this. We'll go to assets, and then we'll just go to login. Or is it not login? I thought it was login. So if I press enter and actually go to the login page. All right, let's just go to the full screen, click login. Oh, it's login.php. That's what it is. So we're going to do admin, and then we'll do QUERTYUIOP, enter. And there we go. We are officially logged in as the admin, and there is the flag on the home page, baby. You just highlight that, copy paste, and you are good. So we got the answers for our section for Cryptographic Failures challenge. Very good. So now let's go to injection. So injection flaws happen when there is a form that you can fill out on a page. So for example, a login form or a support form, anything like that. And it happens because the application interprets the user's input as a command or a parameter, and they depend on what technologies are used and how they interpret the input. And if you don't sanitize the input, which means somebody inputs it, and there's two ways to do it, to actually not even let them do the input. And then so we did one on the I want to say it was the SQL injection room that we did. Let me see, it's inside the path for web hacking. I think it was in JavaScript. It was JavaScript Essentials, I believe. It was JavaScript Essentials where we did some pen testing with doing the SQL scripts. Not SQL, sorry. We did JavaScript scripts, and we put them inside of a support form on a website. And then when you do it, it automatically removes, or it wasn't even, I think it was actually the Burp Suite room. It was definitely the Burp Suite room, because then we used Burp Suite to manipulate the input of that form, because the form wasn't allowing us to actually put scripts inside of the form. It was automatically deleting anything I would type that would be interpreted as a potential script. So because of that, we had to capture it in Burp Suite proxy, and then we changed it inside of the back end of it, and then we forwarded it. So that's what we did. So that's one way of sanitization, where it automatically, as you type it into the form, it just deletes everything. The other sanitization is when you type it and then you press enter, as the server is processing it, it doesn't allow you to submit that information. It just it cleans the input, and then it says the incorrect input or whatever. So injection happens when you put malicious input inside of a form, essentially, or inside of the link at the top of the browser. So SQL injection occurs when the user-controlled input is passed to SQL queries. As a result, an attacker can pass in queries to manipulate the outcome of such queries, and this could potentially allow the attacker to access, modify, and delete information in a database when the input is passed into database queries. This would mean that an attacker could steal sensitive information like personal details and credentials, which what we did with the file that we just downloaded, right? The database file. But we would do it through using actual SQL commands, which is basically what we did on our terminal. So it would be these types of commands where you pass in the what is it, like things like select everything from users. This piece right here, that's basically an SQL command. So if you were able to do an SQL injection attack, you're essentially passing that request or passing that query into the form or into the URL, and then it would process it for you. The other one would be command injection, and this occurs when the user passes system commands into the system and it actually processes it. As a result, an attacker can execute arbitrary system commands on application servers, potentially allowing them to access user systems. The main defense for preventing injection attacks would be to ensure that user-controlled input is not interpreted as queries or commands, otherwise known as sanitization. And using an allow list is very important. So when input is sent to the server, this input is compared to a list of safe inputs or characters. And if the input is marked safe, then it's processed. Otherwise, it's rejected. And then you have stripping input. If the input contains dangerous characters, these are removed before processing. And that's what happened when we were doing the exercise with Burp Suite. When I would try to enter it into the form, it would just strip it before it would even process it. And then I had to capture the session using Burp Proxy and then modify the input on Burp Proxy before I forwarded it, and that was the way that we were able to submit the injection attack. So dangerous characters or input is classified as any input that can change how the underlying data is processed. Instead of manually constructing allowed lists or stripping input, various libraries exist that can perform these actions for you. So let's talk about command injection part 2 technically. So as a continuation of injection, when we go into actual command injection, this is when we send server-side code like PHP in a web application, and then it makes a call to a function that interacts with the server's console directly. An injection web vulnerability allows an attacker to take advantage of that call to execute operating system commands arbitrarily on the server, and the possibilities for the attacker are endless. So they could list files, they could read contents of those files, they could run basic commands to do some recon on the server, or if you wanted to upload a shell file, for example, you could do like a PHP shell file that you can get a reverse shell to that server. And it's as if you're literally sitting in front of the server and issuing commands directly to the command line. Once you have a foothold on the web server, on the web server, we can start usual enumeration of the system and look for ways to pivot around and escalate our privileges or download exfiltrate files, do a number of things that could be very, very harmful to the website, to the company. So let's consider this scenario. We have MooCorp that has developed a web-based application for cow ASCII art with customizable text. While searching for ways to implement their app, they've come across the cow say command in Linux, which does exactly that. Instead of coding a whole web application and the logic required to make cows talk in ASCII, they decide to write some simple code that calls the cow say command from the operating system's console and then sends it back to the content. So if we look at the code, this is what the code that they used for their application. So let's see if we can determine why the implementation is vulnerable to command injection. So this is the code, okay? So if the mooing is set and it actually gives us the get of the mooing variable will get mooing, and then cow is set to default. So we have two variables here essentially. We have the mooing variable and then we have the cow variable. And if it is set, if the mooing variable is set, then it will execute the various commands. So I feel like I'm butchering this because I'm not masterful at PHP. So what I'm going to do is I'm going to feed this because I really do want to give you an explanation. Or actually, no, we have the explanation down here. I don't even need to go ahead and do that. So it will explain it to us in plain terms way better than I did. So if the parameter mooing is set, so first thing, that's what it does. This piece right here, if it's set, if the parameter mooing is set, if it is, the variable mooing gets what was passed into the input field, okay? So pass through, and then we're going to pass the two variables that we have, the cow and mooing variables. Checking if the parameter cow is set. If it is, the variable cow gets what was passed through the parameter, and then the program then executes the function pass through And then the pass-through function simply executes a command in the operating system's console and sends the output back to the user's browser. You can see that the command is formed by concatenating the cow and mooing variables at the end of it. Since we can manipulate those variables, we can try injecting additional commands by using simple tricks. If you want to, you can read the docs on pass-through on PHP's website for more information on the function itself. So this is what it looks like. So if you have your default that is set, so this is what the full command would be, right? So if we have the Perl user bin cowsay, which is the binary that's for cowsay, that's going to execute this command, right? And the default cow, which would be the cow variable, is going to be the first part of the variable that we see right here, right? So that would be this variable. And then we have the mooing command, which is what we actually type over here. And then when you click submit, the cow is going to say TryHackMe because the default cow is going to say whatever we type over here. So if that's the case, then we can try to feed another command into it to see if we can get any other data. So for example, if we echo my username is who am I, then it would say my username is John Doe, right? So that's what the who am I command essentially does. It gives you the username of the actual person. So let me zoom in here a little bit. So on this attack box, right, the John Doe, the J Doe user is the person that's here. So if you actually put in the who am I command without putting it inside of this echo command or inside of this string, if you just do who am I, it's just going to give you the actual username, right? So that's how echo works. So if we execute who am I, it gives us John Doe. If we parse the result back in the outer command, then it would say execute echo. So instead of executing just who am I by itself, it's going to execute echo and it's going to say my name is John Doe, right? So that's basically what this command is doing for us. So coming back to the cow say, if we actually use the default cow again, and then we just put the variable in here, we say $, and then inside the parentheses, we would say who am I, it would actually execute the command. And then it would say, hey, you are Apache. That's basically what it would give as a response, right? It just gives us the output of whatever this command is right here, which is the basic who am I command. So that's how we can enumerate data from a system that is using the cowsay binary. So since the application accepts any input from us, we can inject an inline command which will get executed and used as a parameter, and this can make whatever we want returned by the cow, basically. So we can run a bunch of other commands that are very useful. So who am I, the ID of the user, ifconfig or IP address, that would actually give you the IP address of the machine that you're logged in on, uname, which would give you your host name, and then ps, which would give you all of the processes that are running. So now what we're going to do is we're actually going to run these things, and we're going to do it on port 82 of the web server that we have over here. So we're just going to go literally right there and just change that to 82, press enter, and it will take us to cowsay online. And then I have these various cows that we got over here, which is very, very interesting. And I want to try to see if we can use like other cows or other, instead of default, we could use the other ones. So let's see. What strange text file is in the website's root directory? So we will go here. First and foremost, we need to get our actual current directory. So we're going to say print working directory, and then we're going to submit it. And then the cow is going to say that you are inside of the htdocs directory. So what I want is to list what is inside of the root directory, essentially. So we need to go up one level. So what we're going to do, we could do it a couple of ways. So we could actually do, I'm going to try this one first. So we're going to do the ... and then we're going to do ls. I want to say it's ... /ls. I think that might be the command. Let me see if I don't know if I did it right. I did not do it right. So first let's do this then. So we will just do ... and press enter. Let's see if that works. And it just prints ... So I need to get the, or maybe I can actually, instead of doing that, I can just do change directory, and then I will do ... like that, and it will run it, and then hopefully it will change the directory. And then if I run pwd now, it should give me the root directory. No, I'm still in htdocs. Okay, so let's see here. Let's see what we can do here. Okay, there we go. So the command itself was actually we were going to put it inside the variable, and I did I did ls, and then I did /, which represents the root directory, and then I closed it off in a parentheses. So that's going to list everything inside of the root directory. And now we have everything. So we have the binaries, we have cows, dev, docker, entry point, shell, all these different things that are inside of it. So what was the question? It says, what's the strange text file inside of this? So do we have a strange text file inside of this? Okay, so I mean, I don't see the text file over here. Maybe this is the root directory that they're referring to. So let's change this to root, and let's see if we can get that. It doesn't show me. So what is the root directory they're referring to? That's so annoying. Okay, well, that's pretty annoying, because I know for a fact that when you do something like this, right, if I run print working directory, this is not the root directory. This is the root directory. Okay, so that is what is very, very annoying for me, because now I literally, all we have to do is just do ls in our current directory, which is the hdoc or hsdoc, whatever it was. And that's the text file that they're talking about, the Dr. Pepper text file. That's very annoying. And that's literally not the website's root directory, but whatever. Okay, so the strange text file is inside of the current directory as we're in it, which can be established by just running ls on the current, like literally as you go into it, this is what shows up, and that would be the text file. Okay, so fine. How many non-root or non-service, non-daemon users are there? So we need to find the list of all of the users that we can find that are non-root, non-daemon, or non-service users. So we need to list all of the non-root, non-daemon service users. Okay, so basically all of the users are listed inside of the etc password file. So what we need to do is we need to run the command that would concatenate the contents of the etc password file for us, and then press enter, and then we're going to get a list of all the users. And so we want the non-root, non-daemon. So basically, if you look at, let me see if I'm at the bottom of this thing. If we look at the very bottom of the users list, is when any other users that are non-root, non-daemon, non-system users would be created. So these are all either system or root or daemon. So we have, like, at the very, very top, we actually have root, and then we have binary, daemon, like all of these users are actually root or daemon or system. And it's basically the very first entry right before the :x:. So that would be the user, and then new line, and then user. So the answer would be 0, right? So if we look at the contents of the etc password file, the answer is 0. What user is this app running as? And to find that, we would just run our who am I. So that's what it was. So we'll just go right here. We'll do who am I, run that, and then it says we are running as Apache, so that one's pretty easy. What is the user's shell set as? So if we go, there's a few ways that you can find that. The entry that we were looking for, again, it's inside of the etc password file. So if we do cat etc password, it would give us all of that information. So we're just looking for the Apache user, so we can see what our shell is set as. There's also a way that I know that you can, like, pull the so all the way down here, you can pull the entry for Apache. I forget how to do it. I don't want to digress. My shell, it's not over here. So let me actually, so yeah, I need to find out and how to do it anyway. So let's find out what our shell is. Okay, so upon further research, this is actually the shell, and I had no idea that that was the name for a shell, the S system binary no login. Usually it's like binary shell or something along those lines, or binary ZSH, binary bash, something like that. So I've never actually seen something like this, and I did not realize that this was actually the entry for our shell. And the way that we can, at least I learned this part, that we can do this. So we can do cat of the etc password file. Come on, etc password. And then we can pipe that into a grep command and search for Apache like that. And I just got to make sure that I put that $sign at the beginning and then run that. And then this will just give me the Apache entry. And so it is in the etc password file. And that's what I thought it was. And so this is I believe this would be like the directory that's assigned to this user. And then the actual last segment of it is the location of the bash. So sbin no login is actually the location of our bash. Now we want to know what version of Alpine Linux it is running, and we do that with uname a, and it'll give us everything that there is to know about our system. So if we do uname-a and then press enter, and of course it has to be inside the $sign. So let me show you the command. It didn't save it. Uname a, like that. So that's the full command. So this is the full thing right here. And so we have Linux 5.4.0 AWS Ubuntu da 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 da. So what we're looking for is what version of Alpine Linux is running. And so that would be do we have it? It's not here. So it's not uname. That's interesting. I thought this was the command. Now I'm just losing my mind here. So what's the command that would pull up our version? I think it's like sysinfo. There's a few different things that we can run to see what the version of our Alpine Linux is, but I've literally always thought that it was the uname. So let's see what hint gives us. It can be found in etc Alpine release. So we could just do this then. I can just copy this and I can go here and I can do this. So let's try this out. There you go. That's it. All we needed to do was concatenate the contents of that, which is cat, so $sign. Just assume that everything is inside the parentheses and a preceding $sign. And then so we have cat, and then we have etc Alpine release, and I just press enter, and then it gives us the version 3.16.0. So that was it. All right, moving on to insecure design. This refers to vulnerabilities which are inherent in the application's architecture. They're not vulnerabilities regarding bad implementations or configurations, but the idea behind the whole application or part of it is flawed from the start, as the name implies. It's insecure design. Most of the time, they occur when an improper threat modeling is made during the planning phase of the application and propagate all the way to the final app. Some of the times, insecure design vulnerabilities may also be introduced by developers while adding some shortcuts around the code to make their testing easier. A developer could, for example, disable one-time password validation in the development phase to quickly test the rest of the app without manually inputting a code, but then they forget to re-enable it. And then insecure password resets, which is a really good example of this. And this happened on Instagram. So Instagram allowed users to reset their forgotten passwords by sending them a 6-digit code to their mobile number via SMS. If an attacker wanted to access a victim's account, he could try to brute force the 6-digit code. As expected, this was not directly possible, and Instagram had a rate limiting after 250 attempts, and then the person would be blocked after 250 attempts. So they found out that it only applied to the same IP address, so now they can go ahead and change their IP address, and then now they get another 250 attempts and 250 attempts. So all they needed was 4,000 IPs to cover all the possible codes. And it could sound like an insane amount, but cloud services make it easy to get them at a relatively small cost, making this attack feasible. And if you really want to reset somebody's password, then you can go through this whole thing and just do that. And now you can reset their entire password. So the vulnerability is related to the idea that no user would be capable of using thousands of IP addresses to make concurrent requests to try to brute force a numeric code. The problem is in the design rather than the implementation of the application itself. Since insecure design vulnerabilities are introduced at such an early stage, resolving them often requires rebuilding the vulnerable part of the application from the ground up, and is usually a pain in the freaking butt. So the best approach to avoid such vulnerabilities is to perform threat modeling at an early stage. We call this the move left phenomenon, where if you're looking at the software development lifecycle, the secure software development lifecycle room, and this is actually, there was a video that I did on this as well. And when you look at the software development lifecycle, you just want to move left. So if we were to look at this, let me actually show you this. So this is the software development lifecycle. Okay, so analysis and design are at the very, very beginning of this thing. And as it moves forward, it becomes tougher and tougher to make changes, because if you're already at deployment or maintenance, that means the app is already running. And if you notice something over here, now you have to go all the way back to designing source code and all of that to try to fix everything. So when they say move left, that means instead of doing it here, instead of thinking about security at maintenance, you need to be thinking about security at analysis and design and development, where you're actually developing the source code and all of that. These are the best phases to look at the design security elements and the source code security elements. So when we say move left, we mean instead of doing it over here at the very end, do it at the beginning, and it makes your life so much easier. All right, now, practical example, we're going to go to port 85 on our IP address to get into Joseph's account. It also has a design flaw in the password reset mechanism. Can you figure out the weakness in the proposed design and how to abuse it? So let's try to reset his password. Keep in mind the method used by the site to validate if you are indeed Joseph. So let's go to, what is it? It was port 85. So we're going to go to port 85, and then we're going to try to reset my guy's password. We're going to try to reset Joseph's password. So port 85 is just basically a login screen. At the very bottom right, we have a I forgot my password. And it says, what's your username? My username is indeed Joseph. So we're going to do Joseph, press enter. And it says, what is your mother, assistant, son, nephew's friend's name? What is your favorite color? What is your first pet's current address? So favorite color would probably be the easiest one. And so favorite color. So let's see, blue. That is incorrect. Try again. We will do green. That is incorrect. Try again. We'll do red. Incorrect. Try again. Let's do yellow. Incorrect. Oh, whoops. I keep doing the same question. My bad. Dang it. So favorite color one more time. We're going to do green. Oh, that is his favorite color. Okay. So his favorite color is green. The password for Joseph has been reset to this. So now we have his password. So let me see. Do they want us to give him the password? Okay, so we don't want to use that. We just want to log in as Joseph. So we're now going to Joseph ourselves in. And voila, the note is there. Remember, move private files out of the server. Private files, flag. Let's go. All right, cool. We got it. Let's go to security misconfiguration. Security misconfigurations are different from everything we've talked about so far, and I think different from everything else as well, because it's basically security that could have been appropriately configured, but then it wasn't. So even if you download the latest up-to-date software, poor configurations could actually make the installation vulnerable. Poorly configured permissions on cloud services like S3 buckets. So making a S3 bucket, which is just basically a storage bucket on a cloud service, making the access to that public, for example, that's like stupid, but it happened before and it happened to like a big enough company that it was like, okay, well, that's noticeable. So that's very, very simple and stupid security misconfiguration that could have just been avoided. Having unnecessary features enabled like services, pages, accounts, or privileges, default accounts with unchanged passwords, error messages that are overly detailed and allow attackers to find out more about the system, not using HTTP security headers, so on and so forth. So this vulnerability can often lead to more vulnerabilities, like the default credentials giving you access to sensitive data, XML external entities, or command injection on admin pages. For more info, we can look at the top 10 entry for security misconfiguration on OWASP's website. Debugging interfaces is another one. So the exposure of debugging features in production software is one of the big deals. Debugging features are often available in programming frameworks to allow the developers to access advanced functionality that is used for debugging. an application while it's being developed. Attackers could abuse some of these debug functionalities if somehow the developers forgot to disable them before publishing the application. One of them actually happened to Patreon in 2015. 5 days before Patreon was hacked, a security researcher reported to Patreon that he had found an open debug interface for Workzerg console. Workzerg is a vital component in Python-based web applications as it provides an interface for web servers to execute Python code. Workzerg includes a debug console that can be accessed via a URL on console, or it will be presented if the user to the user if the application is raised by the application, or if the exception is raised by the application. Dyslexia is mad strong right now. In both cases, the console provides a Python console that you can run any code to send to it. For an attacker, this means that they can execute commands arbitrarily. So this is the console, and then you can start typing code. So now we can actually go and do this on port 86 and try to exploit some stuff going on. 86/console is where we're trying to go to. So we are now going to change this IP address here, and we're going to go to 86/console, and console is ready to go. Okay, here we go. So let's see what commands they want us to run. In the console, run the following Python code to run the ls command. So first you have to import OS if you want to run OS commands. And then once you do, you can essentially just run the command. And in this particular case, we are doing OS popen, and then we're going to do ls-l and then .read. So this is a much more complex version of running the ls command, but we're using Python to do it. And then we're using the print function to actually print the output of that onto the screen. So this is the full command that we're going to copy, and we're just going to go over here and we're going to paste it and then press enter. And then now it's going to list the contents of where we're at. So we have Docker file, app.y, requirements, templates, todo.db. So todo.db is a big one. So what is the database file name? And of course it is todo.db. And so modify the code to read the contents of the app file, which contains the application source code. What is the secret flag? So app.py file is what we're trying to run, and the command to be able to run it, it looks like okay, well, we got that. All right, fine. So what we want to do is we want to read the contents of one of these things. So let's see how we could do this. All right, nice. Okay, so we got it. This is the command that actually worked. So this is a basic with open command, and then you just read the contents of any given file. So we know that the name of the file is app.py, and so with open, we're going to open the app.py file in read mode, and then we want to save it as some kind of a variable. So we're going to open this in read mode and save it as file, and then you have to put a colon at the end of a command like this, and usually we would press enter and then put this on a new line, this portion on a new line. But since we're writing everything all in one line, you basically just press space and it's just going to execute it as such in next in order. And then after this, you have to put the semicolon so that you can put this other print function, because this is the body of this. So it's very I have to show you what it actually looks like in normal format, so it kind of makes sense. So this is basically what it looks like when you're inside of a Python editor, and you have the first line that goes like this, and we save it as file, the variable. And then inside of the body of that, we have this other command where we have file contents being saved. So this is another variable. We have file contents being saved as file.read. So when inside of this module, or inside of this header, I guess, because we're using the open function, we can then use the read function. So we'll actually read this file basically because it's in read mode. I'm not here to explain the depths of Python to you, but essentially that's what this looks like. And then the reason why we had to put a semicolon at the end of this is because this one is now outside of the body of this, And so if we're going to put this command outside of the body, we have to put a semicolon at the end of it. So the first time that I actually ran this, I put the semicolon right after the colon because I thought, oh, okay, maybe it's for like every new line, but it's not for every new line. So this entire batch right here, ultimately, it needs to be one full line. And then because you're creating a print function at the end of this whole thing as its own little segment, then you put the semicolon right here. And then the command actually works. And then it opens this in read mode. And then you can actually print the contents of it onto the screen. So essentially, this is what the contents of this is. And then we have the secret flag at the very top, which is THM, just a tiny misconfiguration. And this is the piece that we want to copy so that we can take it for our answer over here. So hopefully I explained that well. If you don't have an understanding of Python, it's going to be a little bit confusing. If that was like the very first time you've ever been exposed to Python, that's going to be a little bit confusing. But if you understand Python, then you should know exactly what we just talked about. And there's multiple videos on this channel about Python. And there are like introductory videos, and then I always point people to the Python for cybersecurity video because it starts from the very, very basics of how to download Python, how to set it up, how to run your first program ever, and then it gets more and more advanced until by the end of the video we create algorithms. So if you've never used Python before, that would be a really strong Python video. If you've used Python before, it's still a really great video because again, it just takes you from the very basics as refreshers, and then you actually learn how to create algorithms by the end of it. So let's move to vulnerable and outdated components. This one's pretty easy to wrap your head around. So there are vulnerable components or outdated components that if they have not been updated or if they haven't been patched, you're kind of SOL. So when you may find that the company entity you're pen testing is using a program with a well-known vulnerability. So let's say that they have not updated their version of WordPress for a few years, and using a tool like WP Scan, you find that it's version 4.6. Some quick research will reveal that WordPress 4.6 is vulnerable to an unauthenticated remote code execution exploit. And even better, you can find an exploit already made on exploit database, which is crazy. As you can see, this would be quite devastating because it requires very little work on your part as the attacker. Since the vulnerability is already well known, someone else likely has made an exploit for the vulnerability already, and this makes it is even worse when you realize that it's really easy for this to actually happen, and it happens regularly. I do use WordPress websites for myself, and it's constantly being updated because there's bugs that people find and they exploit. And then as soon as those things are distributed, if you don't patch or update your WordPress site, you're just asking for it. At that point, you're literally asking for people to hack you. So thankfully, I don't have like any sensitive information on any of my websites because cybersecurity has made me super paranoid. But for the most part, I mean, it's still vulnerable. Like if you don't patch it, and you store a database or like you collect customer information because you have a shop that you're selling stuff on, it's like all of that stuff is super vulnerable if you just don't patch your WordPress site. So it's kind of crazy when you think about it. And that's basically it. So now we're going to talk about the exploits for vulnerable outdated components. Since the whole purpose of vulnerable and outdated components is to exploit something that is known as a vulnerability, most of the work, for the most part, has been done for us in sites like ExploitDB or something like that. There's usually something that pre-exists, and you can run it to try to get what you want to do. So in this particular example, we have this web application that's using Nostromo 1.9.6, 2037 ready for inquiry. What's the story, mother? Whatever. So it's powered by Nostromo 1.9.6. So if we look this up on ExploitDB, we can see that there's multiple exploits for Nostromo 1.9.6, and one of them is a remote code execution, and then there's directory traversal, so on and so forth. So we have at least 3 different exploits in this particular case, or actually we just have 3 different exploits. So that's available, readily available. So the top result happens to be exploit script. Let's download it, try to get the code execution. Running this on its own teaches us a very important lesson. So if we just run this by itself, it says that, what does it say? It says name CV is not defined. So there's a name error for the Python vulnerability here. So the exploits you download from the internet might not work the first time. It helps to understand the programming language the script is on, if needed, so you can fix any bugs or modifications. The error was caused by a line that should have been commented out, so it's an easy fix. So we have this piece right here. This line needs to be commented, as the comment right here says. And basically you just put a hashtag in front of it and this becomes commented, and that's it. So once you do that and then you run it, and then you run it obviously against, let's say, an IP address that you're trying to get. So in this particular case, it is being run on the loopback IP address on port 80, and then they just run the ID command. So it actually feeds back the ID of whatever it is that they're trying to do. And lo and behold, it works. So we have the remote code execution. Now it's time to note that the most important scripts, or most scripts, will tell you the arguments that you need to provide. Exploit developers will rarely make you read potentially hundreds of lines of code just to figure out how to use this. So it's also worth noting that it may not always be this easy. Sometimes you just you may just be given a version number, like in this case, but in other times you may need to dig through the HTML source code or even take a lucky guess on an exploit script. But realistically, if it's a known vulnerability, there's probably a way to discover what the application is running. And that's basically it. That's all we got. So we're going to actually run a lab now on this IP, on this port number, and see what we can get. Yes, so I remember this, the bookstore exercise. So let's see, we need to find the version of this thing. So if we click on this link at the bottom, this is a admin login. So if we click on that, it does not give us anything. So let's go back one more time, and we're going to click on, let's say, contact, and this will also not give us anything. If we click on publisher, it gives us nothing. Let's click on project worlds. Okay, so I didn't really even need to do any research on the actual thing. Basically, on the website itself, it says CSC bookstore. So all I did was I went to exploit database and just searched for bookstore. And on exploit database, we have multiple exploits here. And what is it? Multiple SQL injection, quantity persistent authentication bypass, multiple vulnerabilities. And these are what's available here. So let's see if any of these actually work. Okay, so this is the one right here. So online bookstore, unauthenticated remote code execution. The ID is 47887. And so if we look at this list that I have right here, I got it because I searched for book space store. If you do bookstore together, you're only limited to, I want to say, like 4 results. And then the one that we're interested in is the one that's actually been verified down here. And it's online bookstore 1.0 unauthenticated remote code execution. And this is basically it. So this is the entire script that we want. Now I'm just going to copy the script, and then I'm going to go to my attack box, and I'm going to just paste it inside of a Python file. So I'm just going to open up my terminal here. We will quit SQLite. So the easy way would be to just do nano, and then I'll do bookstore.py, and then I'm just going to paste everything that I have. So this is going to be the full script that we just copied essentially from that place, and then we're going to do Control O, press enter, Control X to exit it out, and then I should be able to run it. So let me see if there's anything else that I need to do here. So I know that we need to have an argument that's supposed to be fed to this, and it seems like the argument needs to be a URL. I don't know why this is not zooming in here, but essentially they have the argument library, the argparse library, and then they also have a URL variable. There's no real instructions here. It just, I guess it, oh, there is a help, the URL of the article or the URL of the target. So yeah, that's basically, that's like the closest thing that we get to instructions over here. So what we're going to do is we're going to just run the script, and then we're going to add the URL of the website that we are going to be scanning or running this against, which is right up here. So we're going to do Python 3 and then bookstore.py, and then I'm going to do 10.10.231.160, and then I'm going to do 84, press enter. And so let's see. Okay, so the proper way to run it actually is you need to put the http:// before the IP address, and then I just put a / at the end of it as well, just for the hell of it, and it actually ran. And so now it says, do you want to launch a shell here? I'm going to say, yes, I do. And oh, we have it. We got the shell. There we go. That is officially a shell. Okay, so ls. Okay, there we go. We literally have the shell. Okay, so what is the question again? It says, what are the contents of the opt.flag file? So we're just going to do cat opt flag.txt, and there it is. Okay. It was, I mean, that was not bad. Like, the hardest part about this was sifting and sorting through these exploits that we have on exploit database to try to find the one. And even that wasn't that hard, because honestly, you just, like, if you want to shortcut the process, you look for the one that's actually been verified, and that's it. That was it. That was the whole thing that we just did for this one. And just like that, there was an exploit that existed, and we just ran the exploit and it worked, and we had a remote code execution. So yeah, moving on to Section 7, Identification and Authentication Failures. Authentication allows users to gain access to web applications or websites by verifying their identities, and the most common version of this is the username and password, which everybody has. A user would enter their credentials, the server verifies them, and then the server would then provide the user's browser with a session cookie if they are actually correct, so if their credentials are correct. A session cookie is needed because the web server uses the HTTPS to communicate, which is stateless, and attaching session cookies means the server will know who is sending what data for that specific session, and then the session can expire essentially when the user steps away or a certain amount of time passes. The server can then keep track of the user's actions during that entire session. If an attacker is able to find flaws in the authentication mechanism, they might successfully gain access to other users' accounts, and this would allow the attacker to access sensitive data depending on the purpose of the application. And some common flaws in authentication include the brute force attack. So if a web app uses usernames and passwords, and then we can try to launch a brute force attack that allows us to guess the username and password using a multiple amount of entries, and if there is no rate limiting and they don't lock us out, we can basically use as like millions of variations to try to get in there. And then we have the use of weak credentials, which there's usually some kind of a password policy. Ideally, there would be some kind of a password policy in place. So it's like at least use one capital letter, one lowercase letter. It needs to be at least 12 characters long. You need to have at least one number in there and a special character, something like that. And then some web applications even tell you that this is a weak password. When you try to set up the account or when you try to change your password, they actually say this is a weak password, try a different password, because they're comparing it against the database like the RockU dictionary, password dictionary, and against that list, which is like something like it's tens of millions of passwords. There's a lot of passwords inside just the RockU list. And so it's comparing it against that list, and it's going to say, yeah, okay, your password, which is password 1, is a really common weak password, and you should not use that because it's in this dictionary. And then anybody that knows how to use John the Ripper or CrackStation, even anybody that knows how to use these tools, they'll be able to crack your password. So we can easily guess them or access the user accounts because they have really weak passwords. And then there's a weak session cookie, and the session cookie is how the server keeps track of the user. So if session cookies contain predictable values, the attacker can set their own session cookie and then use that to access the user's account. So the mitigation for all of these things would be to avoid password guessing attacks, ensure the application enforces a strong password policy, to avoid brute force attacks, ensure that it has an automatic lockout, which is basically rate limiting. So after a certain number of bad attempts or incorrect attempts, it should be locked out. And then the person should be notified that, hey, you've been locked out of your account because of too many incorrect attempts. Then we have the implementing of the multi-factor authentication. So if somebody wants to log in, they should get a secret code texted to them, or a code texted to their email, or some kind of a face scan or a fingerprint, or a Google Authenticator app, or a variety of different multi-factor authentication mechanisms to make sure that it's not just the username and password that they're using to log in to their account. So this is just the theoretic part of identification and authentication failures. And so now we actually get to try a exercise here. We can try an exercise for identification and authentication failures. For this particular example, we're going to look at a logic flaw within the authentication mechanism, and something that happens, and I referred to this earlier in the video, and it's an exercise that we did in the Burp Suite video, is that when somebody has like a form on their website, the developer forgets to sanitize the username and password that's given by the user in the application, which makes it vulnerable to an attack like SQL injection. And then we can focus on a vulnerability that happens because the developer's mistake, but it's actually very exploit, which is the easy to exploit, which is the re-registration of an existing user. So let's say that there's a user with the name admin and we want to access their account. So we try to re-register that username with a small modification. So we will say admin without the actual quotes, obviously. Notice the space at the start of it. So you see there's this little space right here. So it's actually space admin, and then obviously there's no quotes around it. And this is just admin, no space before or after it. So when you enter when we enter this in the username field and enter other required information like the email ID or password or something like that, it'll register a new user, but that user will have the same right as the admin account, and it'll also be able to see all the content that's presented to the admin. So to do this, we're going to register with Darren, and then we'll see that it already exists. So we'll try to register with Darren with the space instead, and then we'll be able to register as Darren and then get access to the flag that's in his account, and then do a variety of other things that are required by these questions. So this is the web application already. This time I was actually a little bit ahead of the game and I loaded it in advance. So if I click on register and I do Darren without the space in the beginning, and then we'll just do Darren@thm.com as the email, and then let's see if we can actually get a password here, and we'll just do password, like a super weak password, and then we'll register. And it says you can't do that because this user already is registered. So I'm gonna go again, try it again, and this time I'll do space and I'll do Darren. So there's a space in front of that, and then it'll still be Darren@thm.com, and then the password will be password again. And then from here, we're just gonna press register. And now it says user registered successfully. So now I can do this. I can do Darren, and then I'll do password, and then let's sign in and see if that works. And it says invalid username. So now I'll do space Darren, and then I'll do password, and then sign in, and it'll actually log me in. And then there we go. So this is the first, I guess that's the first flag, right? What's the flag that we found in his account? And it's right there, right on the homepage. So now it says, now try to do the same trick and see if you can log in as Arthur. What's the flag that you find in Arthur's account? So we're going to log out again, and we're going to go through the same thing, except this time I'm actually just going to put a space in front of Arthur, Arthur, like that, right? That's what we want. Yeah, Arthur. So there we go, Arthur, and then we'll do Arthur@thm.com, and then super weak password, and then we will register, and then it says user has been created, so space Arthur, and then password, and then sign in. And now we are logged in as Arthur. And there we go. We have the flag on Arthur's account. So super basic, right? Like it's not this one is not a complicated hack at all, but this is one of the identification authentication failures that exist on a web application. And this was on the most recent OWASP list, so we can actually consider that this was technically a big deal because it's number 7. It's not even last in line. So this was a big enough deal that it even made it to the list. And something as simple as the exercise that we just ran, where you just put a space in front of the username, that's like, it's crazy to think that something like that could even exist. So you could potentially try to, I mean, legally, obviously you don't want to do this without people's permission because it's a felony or whatever, but this is a simple exercise to run when you're doing a pen test, just to see if you can do this against a website or a web application. So very, very simple exercise, but extremely powerful. As you can see, we can literally get access to essentially anybody's account by just putting a space in front of their name. That's pretty crazy to think about. Okay, so let's go to the software and data integrity failures. When we think about the word integrity, so there's also something in cybersecurity called the CIA triad, where we're talking about confidentiality, integrity, and availability. So integrity is a really big concept in cybersecurity in general. And when we talk about integrity, we're looking at something that has been unmodified, or it's unaltered and nobody changed it in any way. It still maintains its originality. It maintains its original integrity. The integrity hasn't been changed or altered, modified in any way. This is an essential in cybersecurity, as we care about maintaining important data free from unwanted or malicious modifications. For example, let's say you download the latest installer for an application. How can you be sure that when you're downloading it, it wasn't modified in transit or somehow got damaged by a transmission error? So to overcome this, we will look at the hash of these things, right? So a hash or digest is simply a number that results from applying a specific algorithm over a piece of data. When reading about hashing algorithms, you'll often read about the MD5, SHA-1, SHA-256, or any other one. And these are just the variations of this. So if we looked at the WinSCP secure copy setup executable file, right? So if we look at that, we have these various hash values, and these were pre-calculated by the creators of WinSCP, so that when you check the file's integrity after downloading it, you can be sure that if you compare it against the actual value that's on their website, you can be like, oh, okay, so this is actually an unaltered file, because this is what the hash value should be. Because if this file has been changed even in the slightest, then the hash value will be completely different. Therefore, you know that the file has been altered. So to calculate the different hashes, we can use any of these commands: MD5 sum, SHA-1 sum, SHA-256 sum, and then you just give it the name of the file, and then you can give it an executable file, you can give it a Word document, an image, anything. So since we get the same hashes, we can make sure we can safely conclude that the file that we downloaded is the exactly copy that it is on their website. So software and data integrity failures arises from the code or infrastructure that uses software or data without using any kind of integrity check. And since no integrity verification is being done, an attacker might modify the software or data that's passed to the application, and that results in unexpected consequences. Mainly two types of vulnerabilities, which is the integrity failure and the data integrity failure. So a version of this is, I always share this when we talk about hashes and where we're talking about the comparisons of these things, is I'll go to this website right here. So the KaliLinux.org website. If we go to KaliLinux.org, we can download the ISO images, or Kali.org, excuse me, Kali.org. We can download the ISO images of Kali Linux, right? The variety of versions that they have for different operating systems, or for different installer images, or different types of ISO images. For example, the one that you can install on a USB drive, and then now in your pocket, you can take a full copy of Kali Linux that you can boot from any computer, for example, right? So let's say we go to the installer images and we want to look at these images that we have right here, and the net installer. When you click the sum button, they give you the SHA-256 sum of this specific file. So you know that when you download it, in case if anything happened during the download in transit, or I don't know, maybe you downloaded this from somebody's website or something and you want to make sure that it's exactly what it's supposed to be, this is the SHA-256 sum for this specific download file for this version of Kali Linux, which is the net installer version. All packages are downloaded during the installation, so on and so forth. And that's basically it, the installer version here. This is the SHA-256 sum for this file, so on and so forth. So they have this on here because Kali Linux is literally designed for penetration testing. And so it would be silly if they didn't have the MD5 sum, or not the MD5 sum, excuse me, the hash sum value of it. And it would be the SHA-256 sum. So we can just compare that against the download once we've downloaded it by running any of these things right here, any of these algorithms, SHA-256 sum or SHA whatever, and then from there you'll be like, oh, okay, this is actually the download file, or this is not the download file. So when you look at anything that you've downloaded, you can actually compare it against the hash value from their website to make sure that you've downloaded exactly the file that you think you're downloading without the integrity being changed in any way. So that was what we had for the software and data integrity failures. So let's look at software integrity failures more closely. In the video that we did for the introduction to JavaScript, we talk about the fact that we can actually pull a JavaScript script from an external source. So from an external library, a third-party library, for example, and you would just use it by doing script source and then give it the link to the script file. And you could actually do this fairly easily, and it's actually pretty common. It's just that what happens here is that if this particular website has not verified their code, or if that particular website gets hacked and somebody goes and modifies this JavaScript file, when you reference it in your website, when you try to use that code, that means you're now using the hacked version of that code. So what happens is that when somebody navigates to your website, the browser will read the HTML code and then download the jQuery from the specified external source. So somebody requests this, right? And then their request from the website goes to the jQuery.js file, and then jQuery will actually send that file and it'll get processed on the HTML, and then the viewer gets to see whatever that is on the website as they view it. So if somebody hacks into jQuery official repository, they can change this and then inject malicious code in it, and anyone visiting your site would pull that malicious code and execute it into their browser unknowingly, and a lot of things could happen. So this is an integrity failure, as your website makes no checks against the third-party library to check to see if it's changed. And modern browsers allow you to specify a hash along the library's URL so that the library code is executed only if the hash of the downloaded file matches the expected value, and this mechanism is called the sub-resource integrity, and you can read more about it on this particular link, which is, I believe, from the SRI hash generator, and then we have it right in the middle of the page where we see the sub-resource integrity and what it is and how it actually works. So this is the srihash.org website that we have over here. So if you wanted to read more about that, you could go ahead and do that. So the correct way to insert this into the HTML code would be to use SRI and include an integrity hash, so that if somebody, like an attacker, is able to modify the library, any client that's navigating through the website won't execute the modified version, and this is what that will look like. So we have the original script right here that's being referenced as a source. We have the modified version right here. So we have the actual script, right? Source, and still inside of this block, we have another variable that has integrity, which is the SHA-256 sum, and then the cross origin, which is anonymous, and then it just closes out with the script block right here, or the script tag, excuse me. So you have the full thing that's being referenced, and then it just closes out normally as it would, and then right after this source right here, so you see right here, we have the source, and then it closes out with the tag. So right after this segment, we would use the second variable, which is the integrity variable that includes the SHA-256 hash value, and then the cross origin, which is anonymous, and that's it. And then you just close out the tag, and then we can go to this should generate hashes for any library if we need to. So if we go to that website again, now we say what's the hash of this particular thing right here. So we would copy this and then go here and then go right there and then paste it. And then we say SHA, what do they want? They want the SHA-256 hash. So I will go over here and I will select SHA-256, and then I'll say hash it. And then it gives me the integrity, and this is the full hash. So ZO yada yada yada, and it ends with that equal sign at the end of it. And so that's what we have exactly over here. So there we go. We were able to verify the integrity of a piece of code by just taking the link of that code file, that JavaScript file, and then using it inside the SRI hash website, and then it generated the proper version of it for us. So it even gave us the full link if we wanted to go ahead and drop this script code, this block of code, into our HTML for our website, including the SHA-256 hash value. And that is quite useful, believe it or not. I don't know if you're big into web development, but something like that is very, very useful. So that was it for the software integrity failure exercise. Now we can look at the data integrity failure. So let's think about how web applications maintain their sessions. Usually when a user logs into an application, they'll be assigned some sort of session token that'll need to be saved on the browser for as long as the session lasts. And sometimes when you say remember me on this browser, it ends up being like a permanent session token, and that doesn't get erased unless you actually clear your browsing history and include all of your cookies and your caches and everything to be deleted. And when you do that, then the session is wiped. So this token will be repeated on each subsequent request so that the web application knows who we are. These session tokens can come in many forms, but are usually assigned via cookies, and cookies are key value pairs that a web application will store on the user's browser, and that will be automatically repeated on each request to the website that issued them. For example, this is the key, which is the user, and the value is Susan. So if you were creating a webmail application, you could assign a cookie to each user after logging in that contains their username. In all the other requests after that, your browser would always send your username in the cookie so that your web application knows that what user is actually connecting. And this will be a terrible idea security-wise, because as we mentioned, cookies are stored on the user's browser. So if the user tampers with the cookie and changes the username, they could potentially impersonate somebody else and then read their emails. This application would suffer from a data integrity failure, as it trusts data that the attacker can tamper with. One solution is to use some integrity mechanism to guarantee that the cookie has not been altered by the user. To avoid reinventing the wheel, we could use some token implementations that allow you to do this and deal with all of the cryptography to provide proof of integrity without you having to bother with it. One implementation of this would be the JSON web token, also known as the JWT. JWTs are very simple tokens that allow you to store key value pairs on a token that provides integrity as part of the token. The idea is that you can generate tokens that you can give to your users with the certainty that they won't be able to alter the key value pair and then pass that integrity check. The structure of the token is in 3 parts. So the header would be this. So there's a dot right here. I don't know if we can actually see this. So there's a dot that separates each one of these things. So this is the header, and then there's a dot, and then this is the payload itself, and then there's a dot, and then there's the signature. So the header would be the type JWT, the algorithm would be HS256, and that's all in this specific value right here. And then the payload is now the username guessed, and then the expiration would be, I guess, I don't know if that's the number of seconds or a time and date kind of a thing. But that would be the payload. And then from there, we have the signature, which is a bunch of, it looks like, I think it's ASCII. I believe that's ASCII encoding. I'm not really great at recognizing encoding, like just with my naked eye, but it kind of, I feel like it's ASCII. Let's see if it gives us any more information about this. So the header contains metadata indicating that it's JWT and the signing algorithm is HS256. The payload contains the key value pair with the data that the web application wants the client to use. The signature is similar to a hash taken to verify the payload's integrity. If you change the payload, the web application can verify that the signature won't match the payload, and it'll know that you tampered with the JWT. Unlike a simple hash, the signature involves the use of a secret key held by the server only, which means that if you change the payload, you won't be able to generate the matching signature unless you know the secret key. So each one of the 3 parts is simply plain text encoded with base 64. You can use this online tool to encode, decode base 64. Try decoding the header and payload of the following token. So I'm guessing it's going to take us to CyberChef because, oh no, this is a different tool. So okay, base 64 encoder or decoder. So CyberChef is another really, really popular one. You can just Google CyberChef and you'll be able to use its various recipes to be able to do that. So it's very, very powerful tool. So we want to decode the header and payload of this. So I'm just going to take that, paste it in here. I'm going to click decode, or actually, I guess I should click decode first and then paste it. And then now we see right here is JWT algorithm HS256. So that was the header. And then now we have the payload itself, which is this whole chunk right here. So we'll take that, put this over here, and then paste that as our payload. And now we have username, guest, expiration. Oh, so this is literally the same thing that we actually just saw over here above us. So that's fine. Signature contains binary data. So even if you decode it, you won't be able to make much sense of it. So it was binary. It was not ASCII. My bad. JWT and the non-algorithm. So a data integrity failure vulnerability was present on some libraries implementing JWTs a while ago. As we have seen, JWT implements a signature to validate the integrity of the payload data. The vulnerable libraries allowed attackers to bypass the signature validation by changing the two following things in a JWT: to modify the header section of the token so that the algorithm header would contain the value none, and remove the signature part. So taking the JWT from before as an example, if we wanted to change the payload so that the username becomes admin and no signature check is done, we would have to decode the header and the payload, then modify them, and then encode them back. And then encode them back. So notice how we removed the signature part. So now you have just two blocks of text, and then the algorithm has been changed to none, and the username was changed to admin, and then it now created a new coding for us. So it's pretty simple. So let's walk through the process that an attacker would have to go through on this particular IP address, and then follow the instructions below. So I'm going to now go on this IP address and follow those instructions. So this is it: cookies for all, username, password, etc. So let's see the first portion here. It says try logging into the application as guest. What is the guest account password? If the login was successful, you should now have a JWT stored as a cookie in your browser. Press F12 to bring out the developer tools. Depending on the browser, you'll be able to edit the cookies from the following tabs, which is on storage and then cookies, and then we have the cookie right down here. Or depending on if it's on Chrome, it's going to be under application, and it will be able to see the cookie. So if we try to log into the application, what is the guest account password? I guess that would be guest as well. So if I try to log in, it says you can also log in. I mean, that's literally on the screen. So it says invalid credentials. You can also log in as guest with password guest. So I literally just typed in guest as the username and pressed entered with no password, and it just gave it to me on the screen. So that was it. So now that's unbelievable. Okay, so we'll do guest, and then the password will also be guest, and then we will now log in. So if the login is successful, hello guest, only the admin is allowed to get the flag. That's all good. So let's open this up in a wide screen here. And what we're going to do is we're going to look at the source of this page. So we'll go here, we'll inspect it. And then once we click inspect, we can actually go down here and then click on the storage tab. And in the storage tab, we will actually see our cookies. And so we have this cookie right here, which is the full massive thing right here. So let me see if I can double click this. Yeah. So we can actually double click this, and let me see if I can drag it out to display the full thing. And so we can now double click it. I have this full thing. I'm going to copy the full thing. I'm going to go to this website here. And what we want to do is to go ahead and what is the name of the website's cookie containing a JWT token, and it is JWT session. So that's the name of the cookie, is JWT session, and it has that token. So that's that. So now use the knowledge gained in this task to modify the token so that the application thinks that you are the user admin. And then so what we're going to do is we're going to remove the signature, right? So let me go here. I'll go ahead and paste the full thing that I just got here. So this is the full thing that I got. And so I'm going to remove the signature first, okay? And then I'm going to remove, let me highlight this full thing so I can keep that. And then I'll just save it on a little note document real quick. And then what we will do first is we're going to modify the first portion of this, which is going to read here. So it's going to be type JWT algorithm HS256. And what we want to do is we want to change the algorithm to read none, as it says over here. So we will go here. We will change this to none, like so. Let me see if I can, maybe I guess I can't copy that. So I'll go to encode, I'll paste this, and then I'll do none. So there we go. This is going to be our modified algorithm, or our base 64 portion. So I will now paste this on the piece of code that I had saved. So that's going to be my modified version. And then from here, I'm going to go take the other portion that we had here. And so let's get that chunk of text, and then we're going to go ahead here. We're going to decode this piece. So it'll say username guest, and then so on and so forth. And then so we're going to take that over here, we're going to paste that here, and we're going to change this to admin. And then now we get to take this full piece and then go and paste that with our last piece. So now we have this full chunk of text, which I have right here. So now I will go ahead and take that, bring it here. So, I mean, for literally all I did was, so I'll show you the full thing just so you can see what the full thing looks like. So it is this right here. So this is the modified version that we just created. So this initial one is me changing the algorithm to none, and then there's that dot that separates it, and then this last piece is the one where I changed the username to admin, and then we just encoded it. So that's basically it. Now we piece all of these things together, and now we have this. So we're going to go inside of the browser down here, and we're just going to go for this section, and we're going to paste it here, and that'll be that. And then so now I guess I press enter and refresh the page. Either the token or signature is invalid, no flag for you. So let's see. I see. So there's literally a dot that's also supposed to go at the very end of that second portion. And so I did not include my dot in my cookie. I just had the full piece right here. So I'm going to go here. I'm going to delete that one more time. I'm going to paste the cookie that I got. And then at the, nope, that's not the cookie that I got. So let me go ahead and actually make sure that I have the right cookie. That's the first important part. So we just want to make sure that we have the right cookie. So let's copy this bad boy here and then bring it back over here. And then we're going to take this whole thing and then we're going to paste it. There we go. That is the right cookie. And now I'm just going to put a dot at the end of this, press enter, and that will say, okay, so that's saved. So I think now I can just refresh the page, and there we go. All right, so there it goes. It worked. So all I was missing was basically just the dot at the end of this whole thing. So everything that we did was correct up until the point that I was just missing that last dot at the very, very end of it like that. And now this is the full thing, and then you just submit that. And you press enter. So I modified the cookie right here. So I double clicked that. I erased it. I pasted the value. I did the dot, pressed enter, and then I refreshed the page. And then boom, we have our flag. So very good. That worked like a charm. Excellent. All right. So let's talk about security logging and monitoring failures. All right, when web applications are set up, every action that's performed by the user should be logged, okay? This is a concept that is, I mean, it's literally as old as IT and cybersecurity itself. So logging is important because in the event of an incident, the attacker's activity can be traced. We call this incident response or digital forensics. So once their actions are traced, their risk and impact can be determined. Without logging, there would be no way to tell what just happened. We have regulatory damage that we need to take care of, which is an impact that is a really big piece of an attack that takes place. So without logging, there would be no way to tell what actually happened. And then the more significant of those impacts could actually be the regulatory damage, meaning that you can, by the regulatory environment, so HIPAA or GDPR or something like this, right? So if an attacker has gained access to personally identifiable user information and there is no record of this, final users are affected and the application owners may be subject to fines or more severe actions depending on the regulations of their industry. And then there's a risk of a further attack. So the attacker presence may be undetected without logging, and then you don't know who it was or what they did. And they could just do it again, right? Or they could do even worse stuff the second time around. So the information that's stored in logs should include the status codes inside of it, the timestamps, usernames, API endpoints or page locations, and the IP addresses, for example, the source IP and the destination IP of that transaction or that communication that happened. These logs have some sensitive information, so it's important to ensure that they are stored securely and multiple copies are stored at different locations for backups. As you may have noticed, logging is more important after a breach or incident has occurred. The ideal case is to have monitoring in place to detect anything in a live environment. The aim of detecting this suspicious activity is to either stop the attacker completely or reduce the impact that they've made if their presence has been detected much later. And common examples of this activity could be multiple unauthorized attempts for a particular action. So trying to log in, for example, you get multiple login attempts unauthorized login attempts to an admin page, or requests from an anomalous IP address or location. This can indicate that someone else is trying to access a particular user's account. It could also have a false positive rate. Use of automated tools, so scanning tools, for example, or the value of user agent headers and the speed of the request. That could be one of the things that will be like, oh, okay, somebody's using Nmap, for example. That would be the user agent header. It's like somebody's using Nmap to scan us. Or if there are a lot of ping requests or something that are happening, it's like, okay, well, what is going on? We just got a million ping requests or pings in the last like 10 seconds or something from this IP address. It's like, okay, that's definitely not right. So this can indicate that the attacker is using an automated tool. And common payloads. So in web applications, it's common for attackers to use known payloads, like what we did with the exploit database payload. That's a pre-existing payload. And we were a script kiddie in that situation where we're using somebody else's script, somebody else's exploit to attack. So detecting the use of these payloads can indicate the presence of someone conducting unauthorized malicious testing on applications, and detecting suspicious activity just by itself isn't helpful. So this needs to be rated according to the impact level. So certain actions will have a higher impact than others, meaning there's low criticality or critical criticality, or I guess severity. We can have low severity or critical severity. The higher impact actions need to be responded to sooner. Thus, they should raise alarms to get the relevant party's attention. Putting this to use by analyzing the provided example log file. We can download it by clicking the download task files button at the top of the task. So let's go ahead and do that so that we can try to access this specific log file here. All right, so this is the log file. We have several items at the top right here that got a response code of 200, meaning that they were processed. And then we have unauthorized requests right here, trying to log in as admin, administrator, anonymous, or root. And they were all trying to go to the login page. And this, I am guessing, is the source IP address that was trying to do the whole thing. So 49.99.13.16 is the source IP address. So the first question here is telling us what is the IP address that the attacker is using, which is at 49.99, and what kind of attack is being carried out. And if we just look at it, they're literally trying to log in as any user that they can possibly do, and they're trying to access the login page by these various users, and every one of them is unauthorized responses, which means that they're trying to just brute force the login on our login page. They're trying to access by brute force, which is the type of attack that is being carried out. So that's the value of a log file. You just need to know what you're looking for. And then thankfully, there's a lot of tools like intrusion detection systems or SIMs that will make this a lot easier for you. There's endpoint detection and response systems, endpoint security. There's so many different automated tools that as long as you have your log files loaded or you have your web pages being monitored in a live environment, you'll get notifications as it's happening, and then you'll know what's going on. You don't have to know how to read these things. The alerts will just pop up to the screen. Obviously, it's really good to know how to read a log file, and this isn't complicated, right? This is the timestamp that happened. This is the page that was being attempted. This is the usernames that were being attempted, or the data that was being posted to it. We can think about it like that. The response codes were 401 unauthorized, and then these were the IP addresses that were trying to access it. It's not complicated, right? So it's very, very simple to read that log file at the very least. Some other log files are a little bit more complicated, but usually, as long as you have like an understanding of the general type of log that you're looking at, you'll know what kind of data is being presented to you, and then everything's all good after that. You can decipher the information fairly easily. So let's move on to our last OpenWASP top 10, OWASP top 10, OpenWASP. I don't know why I said that. OWASP top 10 items, so which is the server-side request forgery. This vulnerability occurs when the attacker can coerce a web application into sending requests on their behalf to arbitrary destinations while having control of the contents of the request itself. That's kind of complicated, so let's talk about it a little bit deeper. These vulnerabilities often arise from implementations where the web application needs to use a third-party service. So for example, a web application that uses an external API to send SMS notifications to its clients. For each email, the website needs to make a web request to the SMS provider server to send the content of the message to be sent. And since the SMS provider charges per message, they require you to add a secret key, which they pre-assign to you to each request you make to their API. The API key serves as an authentication token and allows the provider to know to whom to bill each message. And this application works like this. So this is the API at the top right here, and then you have that API call that's happening inside of the URL, and then it's sending the SMS, and then it's getting the SMS server right here, and then the message itself is hello, right? So the request that we're getting is my site, we want to get SMS, and then we want to access this server, and the message is going to be hello. So what's going to happen is that through the power of the internet, our website is going to forward the SMS provider using that key, which is the API send message, and then it actually gives it the secret API key as well. And it's going to go to this server, which is our SMS sending server. And then it's going to submit that submit that request, excuse me. And I skipped this step, so my apologies. So the request is what we are seeing right here. The query is going to be billed. So it's going to be turning this whole thing into, all right, we're going to query this specific website, which is the service or srv3sms.thm, which is this piece right here. So we want to get the SMS server for this and then send that message. And then so this is what we're accessing, that actual domain name, and then the API send the message hello. And then this is going to be the query that's going to be built, and then that query is going to be sent to the actual service for the SMS, the server, and then it's actually going to send the message that we want, as long as we have our secret API key that goes along with our query that came from our website. And you usually get a secret API key anytime that you create some kind of an API connection or integration. You get your own API key so that you can actually use that API. So this is something that's easily accessible as long as you have an account with whatever the application or the service is, which is in this case the sms.thm server. So by looking at that diagram, it's easy to see where the vulnerability is. The application exposes the server parameter to the user, which defines the server name of the SMS provider. If the attacker wanted, they could simply change that to a machine that they control. So instead of it sending to the srv3.sms.thm, which is this website right here, which is inside of the URL. So instead of sending it over there, then we can just send it to the attacker.thm. And then that would be the server, and that would be a domain that we would control, and then we could essentially manipulate this any way that we want. So as part of the forwarded message, the attacker would obtain the API key, allowing us or allowing them to use the SMS service to send the messages at our expense. So this would only need to make the following request or the following modification, which is this piece right here in the overall URL. And then it would make the vulnerable web application make that request to the attacker.thm, and then everything else will still be the same. So you could then capture the contents of it using Netcat, as long as you're doing it against your specific domain, which is in this case attacker.thm, and then you will listen on port 80 because that's the web port, and then hopefully it'll actually connect, and then you'll be able to get that session and do whatever you want on that web application. So this is a very basic case. Obviously, if it doesn't look that scary, it can actually be used to do much more in general. Depending on the specifics of the scenario, you can enumerate internal networks, including IP addresses and ports, abuse trust relationships between servers and gain access to otherwise restricted services, interact with non-HTTP services to get remote code execution. So we can do this in a lot of different ways. You could do a lot of crazy things. So we're actually going to try this. So we're going to go to port 8087 on our IP address for our victim machine over here, and then this is the website right here. So I will look at it in the full screen mode so that you can see what's going on. So it says explore the website. What is the only host that's allowed to access the admin area? Check the download resume button. Where does the server point to? And then using the SSRF, make the application send the request to your attack box instead of the secure file storage. Are there any keys in the intercepted request? And then go the extra mile. there's a way to get the SSRF to gain access to the site's admin area. Can you find it? You won't need this flag to progress in this room, but it would be cool if we were able to find it. So first, let's go ahead and close this right here. And the first question was, who's the only host allowed to access the admin area? So if I click on this menu right here, we can go to our admin area, and it says admin interface only available from local host, which would be 127.0.0.1. Technically, that could be our local host, or it could be localhost by itself. So from here, localhost is the answer to the first question. Now it says check the download resume button. Where does the server point to? So we're going to go back one, and then we're going to click on portfolio, I think, or is that what this is? Let's see, download resume. Boom, there it is. So it would be on the portfolio. Click on the download resume, and it actually points to this is literally on our local website. It's file root download PDF. So this is literally pointing to the oh no, it's not. So it says check to download. Where does the server parameter point to? So I don't even see the server parameter. So this is my download resume. It says file download PDF, so it doesn't show me what the server is in this particular case. So let's actually look at this link. So I'm going to copy the link, and then I'm going to paste it because I think it just opened the file itself. So this is where it points to. There we go. That's the actual link of the download resume, and it points to the securefilestorage.com. That's where it's pointing to. So there we go. Securefilestorage.com is indeed the answer. I should have looked at that a little bit more carefully. So now, using SSRF, make the application send the request to your attack box instead of the secure file storage. Are there any API keys in the intercepted request? So let's see. If I send it to my attack box, now I got to modify this a little bit and mess around with it. So that's the IP address of my attack box. So I'm going to modify this and see what we can get. Okay, so when I modify the link to actually point to my attack box, this is basically what it looks like right here. You could either use HTTP or no HTTP, but basically this is the IP address of my attack box. Okay, when I press enter on this, this is the response that I get, and at the top it says it's failed to connect to that IP on port 887, which means I actually need to establish that netcat listener. So I'm going to create a netcat listener real quick, and let's just use the same flags that they used in there. So LVP, and then they did it on port 80, but we're doing it on port 8087. That's the port that this is trying to connect to. So what we're going to do, let me get my terminal back up. So we're just going to do the netcat, and then we're going to do LVP, and then we're going to do 8087, press enter, and now we're listening on port 8087. So I'm going to go ahead one more time, press enter, and let's see if we get any kind. Oh, it's actually still processing, so it didn't automatically give me any kind of an error message. And on the background, we actually got that connection. So it says connection received on this specific IP. And then what do we get? We got the API key too. So there we go. That's our API key. And that would be the answer, the final answer to actually be able to process this. And so now it says there's a way to use SSRF to gain access to the site's admin area. Can you find it? So this is not required. So I'm going to just try. I'm going to try to see if we can actually do this. Okay, so in order for this to work, we need a few pieces of data. So number one, it says it can only be available from localhost. And then this is on the /admin domain. So if we go back over here, and I'm going to just stop my netcat listener real quick so we can just close this out. And just if we need to do that again, we'll just do it again. In this particular case, we need to change the server to this specific thing, which is going to be our HTTP and then /localhost dot and then I think admin, localhost admin, I believe that's what it is. I don't know if there needs to be a .com here. We can try it. We can try multiple variations, but we can only access it from the localhost /admin. And then, so let me see what happens if we do this. Still, we get an error. Okay, so let's do some, testing. We're going to do some trial and error here. Oh, interesting. Okay, so that worked. This is actually the flag that is available for the admin, and it's a PDF document that downloads. And the link that got us here is this. So we did the HTTP localhost. Admin is actually supposed to come after the port number. And then this right here is a URL encoded hashtag. So the way that I just went to a URL encode, and this is mostly because this is a way that we just created these links. Oh, interesting. So this actually worked, and basically it's just another PDF file that gives us the flag right here. This is the final URL that made it work. And originally, so if you're going to include a URL inside another URL, you need to make this whole thing be treated as if it's one entry. And in order to do that, you would put a hashtag at the end of it. And then the ID and everything still needs to be here. Now, if you put an actual hashtag at the end of it, it treats it as that it's like a fragment kind of a thing where it'll go to the part of the web page. So when you have a hashtag inside the URL, it'll try to find something in the web page that is, for example, ID equals whatever, and then it'll try to go to that portion of the web page. But we don't want it to do that. We want it to actually treat it as a literal hashtag so that it can treat this whole piece as one item instead of treating it as, okay, this is the link, and then this is the port number, and then this is the path that we were trying to go to. So to do that, we would actually turn this into an %23, which is a URL encoded hashtag. So that's the way that the server will treat that hashtag as instead of treating it as trying to find something on the page, it'll actually treat it as a literal hashtag, and then it will turn this whole segment into one item, and then it'll turn the full URL that you see here as one full item instead of having a URL that's inside of this URL. So the way that I did that, it was literally just go to I did URL encoder on Google, and then it brought me to this web page, and then from here I had that hashtag in here, and if you just put a hashtag or literally any character and then do encode, it'll just give you the URL encoded version, which is %23, and then we put that in the URL, and so the full URL ends up being the localhost on the port 8087/admin. So the /admin actually comes after the port, and then from there you would do the %23 so that it's a literal hashtag, and that the ID also still needs to be here in order for this whole thing to work. And then so when you press enter on this, you would end up with this document being presented on your page. It also downloads the document on the machine as well. And this is it. This is how we get our last flag. So this was actually a learning curve for me. I had to go and get some education on server-side request forgery and how to create a URL like this, because I'm not very experienced on it. So we both got to learn something interesting together, and we got the extra credit that was available on this particular task for this exercise. All right, so that was it for this entire room and this entire video that we did on OWASP Top 10. This was a really good way to conclude the web hacking module that is inside of the CySec101 pathway of TryHackMe, and I really hope that you learned a lot when we went through this. This was a great refresher for me personally, and I actually got a lot out of it as well. So I really hope that you also got a lot out of this particular exercise and this video that we went through. And to get more stuff like this, I would encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out, especially in the CySec101 playlist and this training series. And there's a lot of videos that are already on the channel that you can definitely go check out. There's a lot of playlists, and there's more playlists coming out. There's Network Plus that's going to be coming out in the next week or so. And then after that, there's the AI integration with cybersecurity tools, which is a very, very big deal. So learning how to train AI is going to be one of the ultimate skills in the next 5, 10, 15, 20 years, because everything, as you can already see, is turning into AI. So all of that stuff is coming out. So again, I encourage you to like, subscribe, and turn on notification bell so that you get notified when those things come out. But then also, I just want you to check out the comment section, because we really do have a lot of comments that come in from the community, and I'm very responsive in the comment section, and I will answer anything that comes in. If it's like a quick little response, then I'll respond to you in the comment section directly. If it requires a longer response, I'll create a video in response to your question, or even a playlist. So this entire CySec101 playlist is something that is in response to Darnell Knight. I give him a shout out whenever I can. And so I am active in the comment section. I do respond to everybody in the comment section. So on top of liking, subscribing, and turning on the notification bell so that you get notified the next time that a video comes out, I do encourage that you drop a comment to ask a question, if you just want to say hi, or if you want to say thanks. You can also say thanks by supporting this channel and joining the Hackaholics Anonymous community, which is the premier community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master, and each tier gets their own Discord server and early access to content. The agent, guardian, and master levels, however, get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, and so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. I hope I see you in the Discord servers and the Discord chats. If not, I hope I see you in the comment section on the channel, and that's it. It's your boy Hank Hackers, and at Hank Hacks Hackers, if you're ever network and system attacker/protector, love, peace, and chicken grease. If no one else loves you, Hank loves you, and I'll see you in the next video. Peace.